Hey there, it's Mrs. Key, and we are going to be able to define zero and negative exponents by the end of this lesson. I hope you guys have your notebooks out and you're ready, and I hope you're having a good night. Alright, let's start off by titling our paper, Zero and Negative Exponents, and our essential question is, how do I define it? The first thing about zero exponents, and we learned this in our pattern today, is that any non-zero number, so 1, 2, 3, 4, 5, 6, 7, 8, to the zero power is equal to 1. By the way, 0 to the 0 is undefined. Okay, the second thing, negative exponents for any integer that's positive and negative whole numbers, and any number a not equal to 0. Okay, so for any integer exponent and any base that is not equal to 0, a to the n, number to the negative exponent, is equal to a to the 1 over a to the n. It's a fraction with that exponent. Alright, let's go try some examples. Alright, example number 1, we have 4 to the negative 2. And remember, for any integer base and negative integer exponent, you can rewrite this as 1 over 4 squared. It says evaluate, so we're going to go through and we're going to finish our multiplication in this. So this is going to become 1 over 4 times 4. And 1 over 4 times 4 is 1 over 16. Alright, number 2, again, these both have integers, and so we're looking at 1 over negative 2 to the 5th. The exponent is what changes from a negative to a positive, and now we're going to do 1 over negative 2 times negative 2 times negative 2 times negative 2 times negative 2. 1, 2, 3, 4, 5 negative 2's. Okay, now we're just going to go through and multiply those negative 2's, and we'll have 1 over 2 times 2 is 4, 2 times 2 is 4, 4 times 4, 4 times 4, I went through and simplified these two. 4 times 4 is 16, and 16 times negative 4 is going to leave us with a negative 2, sorry, not negative 4. It's going to leave us with a, let me go through 16 times 2, 2 times 6 is 12, 2 times 1 is 2 plus 32, negative 1 over 32. Alright, number 3. Let's go ahead, these are two same bases with a multiplication to them, so between them, I'm going to add our exponents because that's our product of powers rule. So 6 to the negative 8 plus 8, 6 to the negative 8 plus 8 is 6 to the 0, and evaluate 6 to the 0 is 1. Anything to the 0 is 1 except 0. Okay, number 4, I'm going to use our quotient of powers, so we're going to subtract our two exponents. Now I'm going to have negative 3 to the 5 minus 6. Super important, order matters. Now this is going to be negative 3 to the negative 1. Alright, now we're going to make it that fraction. We don't like negative exponents. 1 over negative 3 to the first exponent, which is all just negative 1 over 3. Same thing. Okay. Number 5. Number 5, we're going to multiply our fraction, and so we'll have 1 over 5 to the 7th times 5 to the negative 4. Product of powers in the denominator, so 1 over 5 to the 7 plus negative 4. Okay, now we'll have 1 over 5 cubed, and that will be 1 over 5 times 5 times 5, and it does say evaluate, so 1 over 125. 5 times 5 is 25, and then 25 times 5 is 125. Awesome. Let's go to number 6. We're going to use our product of powers right here. So 4 to the 5 plus negative 3 over 4 squared. 4 to the 5 plus negative 3 is 4 squared over 4 squared. Now we're going to use our quotient of powers and we're going to subtract. Now we'll have 4 to the 2 minus 2, which is 4 to the 0, which is 1. Awesome. Let's go on to example 7. Simplify. Write the expression only using positive exponents like what we did before. So our last couple, we have 8. And this does not have a parentheses around the 8 and the x, so this is just talking about that x being negative to the x squared. Oops, sorry. And we can't simplify this any further because we don't know what x is, so we're done. We don't know what x is, we're done. 8, same bases, they're both b's, so b to the 0 plus negative 10. Okay, so this is b to the negative 10, using only positive exponents because we don't really like negative exponents in math. This is going to be 1 over b to the 10th. And now we're done. Because we don't know what b is, this is as far as we can get. Okay, last, let's go ahead and look at number 9. We have two z's that have the same base, so we're going to have z to the 6 minus 9 over 15. That 15 has to stay in that denominator because we're not moving it. Okay, so 6 minus 9 is negative 3. Z to the negative 3 over 15. And now we're going to put that z back in the denominator to make this positive. So it's going to be 1 over 15z cubed. And this 9 right here in that very beginning only goes to the z. If it was talking about the 15 and the z, they would have the parentheses around it, and they don't. Alright, go ahead and try these on your own problems. Please pause your video and resume when you're ready to check your answers. Thanks for pausing your video. For this problem, you should have gotten 1 over 125 because it's negative. This one is 1. This one, you should have got a negative exponent at first, and then you should have put 1 over 3 to the 4th exponent, and that's 3 times 3 is 9. 9 times 3 is 27. Did I say 9 times 3? 9 times 3 is 27, and 27 times 3 is 81, so this is 1 over 81, because it does say evaluate. This next one, we're going to have 1 over, add these two exponents together, 2 cubed, and 1 over 2 cubed is 2 times 2 is 4, 4 times 2 is 16. No, 8. What am I saying? 1 times 2 is 8. Okay, next, we're going to add our two bases together first, and then we'll get 2.3, oops, that's not a 3, 2.3 to the 4th over 2.3 to the 5th. Okay, now we're going to subtract our exponents, and we'll get 2.3 to the negative 1, so 1 over 2.3, which is not very pretty. We don't really like that in math, but this is what you get for this problem. Alright, go ahead and answer this essential question, and go take that checkpoint. I hope you guys have a good night. Later.